Hi students, today we'll discuss about the discrete distributions. So in your syllabus mainly there are three distributions are there: Bernoulli, binomial and Poisson distribution. These three are discrete distributions. Why? Because of in these distributions the random variable is discrete, like number of heads, number of trials, number of players in a cricket team, like that number involved. That's why these are the discrete probability distributions. The first one is Bernoulli distribution. In Bernoulli distribution only one trial is there. In that one trial is also just only either success or failure. That's why 0, 1 only involved. So a discrete random variable x assumes two values 0 and 1 with the probability mass function p of x is p power x into q power 1 minus x, x range is 0, 1 equal to 0 otherwise. Here p is probability of success, q is probability of failure. This p of x is called the Bernoulli distribution with parameter p. Actually in the function there are two letters like p and q, but only one parameter. Why? Because of q can be expanded in terms of p. Q is 1 minus p. That's why only one parameter involved here, p. Then how to derive the moments of Bernoulli distribution? So you know very well about the moments in terms of expectation, the expectation in terms of summation. That's why rth moment about origin consider mu r dash is expectation of x power r. So summation x power r into p. Here we consider summation. Why? Because of x is a discrete RV. So summation x power r into p of x substitute now p power x into q power 1 minus x. First x equal to 0 substitute, 0 into anything is 0 plus 1 substitute 1 power r into p power 1 into q power 1 minus 1. So 0 plus p, it gives p. So mu r dash is p in the sense no r is there. That's why whatever the r value is substitute, it gives only single value. So mu r dash is 1, r equal to 1, 2, 3 and so on. Mu 1 dash is p, mu 2 dash is p, mu 3 dash is also p, mu 4 dash is also p. So that's why mean is here p. Now we find variance. Mu 2 is mu 2 dash minus mu 1 dash square. Mu 2 dash is p minus mu 1 dash in the sense p square. P considered as common, p into 1 minus p, it is q. Variance is pq. So the mean of Bernoulli distribution is p. Variance of Bernoulli distribution is PQ. Now how to derive the MGF of Bernoulli distribution? So this MGF is very familiar thing in the distributions. So for any distribution, how to define MGF in the sense mx of t is expectation of e power tx. In the last session we discussed clearly about MGF. So it is for discrete, that's why summation e power tx into p of x. Summation e power tx into your p of x is here. P of x is p power x into q power 1 minus x. That here we substitute. So once we substitute that here, so what happened? Check it. Summation e power tx into p power x q power 1 minus x. X equal to 0 substitute, but e power 0, p power 0, q power 1. 1 into q plus 1 substitute here, e power t plus p power 1 q power 1 minus 1 p e power t. Finally mx of t is q plus p e power t. So which is the MGF of Bernoulli distribution. Explain about Bernoulli distribution in the sense first you should write the definition, then derive mean and variance. After that MGF is also considered. So it's very simple and basic distribution. So easy only. Now we enter into the main discrete distribution. It is binomial distribution. So it's very familiar one. So easy also, better concentrate more on binomial distribution. This binomial distribution was discovered by James Bernoulli. This is most widely used discrete probability distribution. It is a random experiment. So if a random experiment is repeated n times with two mutually exclusive outcomes, success and failure in each trial. See, only single trial considered means it is Bernoulli distribution. Same trial more than one time consider, it is called binomial distribution. Only one trial in the sense Bernoulli, more than one in the sense binomial. That's why binomial distribution is like n Bernoulli trials is called the binomial experiment. So the total number of success is a random variable with the value 0, 1, 2 and so on n. In this situation, if we treat every trial as Bernoullian, then n independent Bernoullian trials with the probability of success is constant in each trial is called a binomial experiment. So constant in each trial in the sense, suppose there you consider when 4 coins are tossed, what is the probability of getting 3 heads suppose. That type of situations, first trial, what is the probability of getting head means 1 by 2. Second trial is also 1 by 2. Third trial, every trial, the probability of success is same in the sense, it is only the Bernoulli trial. Actually, that type of n Bernoullian trials we consider, it is called the binomial experiment. So, what are the different situations or conditions involved in the binomial distribution means, number of trials must be finite. Each trial results in 2 mutual outcomes, success and failure. The trials are independent, everyone knows very well. The probability of success P is constant in each trial, it is also. Then how to define the binomial distribution. So a discrete random variable x assumes the value 0, 1, 2 and so on with the PMF. P of x is NCX, P power x, Q power n minus x. X is 0, 1, 2 and so on n equal to 0, otherwise is called binomial distribution with parameters n and p. By seeing this P of x, here n is there, P is there, Q is also there, but Q considered as 1 minus P. Then X is a random variable. That's why parameters are N and P here. Usually it's denoted by X follows B of N comma P. Means X follows binomial distribution with parameters N and P. Now, look at this statement here. So, summation P of X is 1. Summation P of X in the sense this respective function here. So, it is of the form of binomial expansion. What's the binomial expansion in the sense? Like x plus y whole power n. Here x is q, y is p, like q plus p whole power n. Q plus p in the sense 1 power n is 1. So, summation P of x is 1. Sometimes they consider instead of this q plus p whole power n, instead of the q another term is there, suppose that term consider, instead of the p another term is there, suppose that term you consider. This is the standard format for binomial distribution. Then moments of binomial distribution. One more thing, in your syllabus only statements are there for all the properties. So related sums are also involved. That's why no proofs, nothing here. So moments of binomial distribution consider non-central moments in the sense mu1 dash, mu2 dash, mu3 dash, mu4 dash. So all this everything is known only for you. Why? Because of these concepts already discussed in the first semester. So mu1 dash is NP, mu2 dash is expectation of x square, expand in the sense like that, they will get mu3 dash, mu4 dash. All based on non-central, we find the central moments. Mu1 is 0, mu2 is NPQ, mu3 is like mu4. So coefficient of skewness beta 1, coefficient of kurtosis also consider. So based on Q and P values, there we consider the behavior of the distribution also. Once we find the beta 2, it gives 3 plus. That's why this distribution is mesochaotic. So that mesoplatty left also when it possible in the sense based on 6pq value. Then generating functions. There we consider all the 4 generating functions, MGF, CF, PGF and CGF. So MGF of binomial distribution is q plus p e power 12 power n. CF also like that only. PGF also similar. CGF is log mx of t. Substitute that and simplify. Then relationship between cumulants and moments of binomial. K1 is mu1 dash, you know very well, it is NP. K2 is mu2, it is NPQ. K3 is mu3, K4 is like that, they will derive mu4 in the sense K4 plus 3 K2 square substitute. Then additive property of binomial distribution. If x1 and x2 are two binomial variates with different parameters, Then x1 plus x2 is also a binomial variate with parameters n1 plus n2 comma p. Like mode of the binomial distribution also consider n plus 1 into p based. It is an integer. So that value and before value is called the modes. If it is not an integer, that integral part of n plus 1 into p is called the mode. So basing on this, they consider some problems. First one, the MGF of a random variable x is some function given here. Find the distribution, mean and variance. So you know that MGF of binomial distribution is q plus p e power t whole power n. This is of the form of mx of t only. Q is 2 by 3, p is 1 by 3, then n is 9. So basing on these three values, consider the distribution in the sense p of x, ncx, p power x, q power n minus x. 9cx, so 1 by 3 power x, 2 by 3 power 9 minus x. Like np in the sense mean, so mean is np, substitute that, it gives 3, variance is npq, so respective values substitute and simplify. Then second problem, the mean and variance of binomial distributions given, find the p of x equal to 1, p of x greater than or equal to 2. So based on mean and variance, you should find the p of x first. Mean of binomial is np is 16, variance is npq is 8. By using these two equations, you get p and q values. npq by np, 8 by 16, 1 by 2 q. Then p is 1 minus q, it is 1 by 2. Then basing on that, n find. N into 1 by 2 is 16, n is 32. Then PMF of binomial distribution is p of x is ncx, p power x, q power n minus x. So 32cx, 1 by 2 power x, 1 by 2 power 32 minus x. Simplify this. Then p of x equal to 1 substitute and simplify. P of x greater than or equal to 2 means, so 2 plus 3 plus like that 32 considered in the sense it's somewhat difficult. That's why I go through that another area here. 1 minus p of x less than 2. Less than 2 in the sense p of x equal to 0 plus p of x equal to 1. So 1 minus, substitute and simplify, it gives some value. No simplification, nothing, substitute and so minimum simplifications you can do. The mean and variance of binomial distribution is given. Find p of x greater than or equal to 1. Mean and variance based, you get find that n value, p value and q values. So p of x, consider p of x greater than or equal to 1 means 1 minus p of x less than 1. Less than 1 in the sense p of x equal to 0. Substitute and simplify. The mean and variance of binomial distribution are 3 and 4. Find the distribution. So np is 3 given, npq is 4 given. So npq by np, it is 4 by 3, q is 4 by 3, 1.333. It is only the obligation here. So q value is always less than 1. So but here you get 1.333. That's why it's not possible here. That's why the given data is not correct data. Then next problem, 5 coins are tossed simultaneously. Find the probability of getting 3 heads, at least 1 head, at most 2 heads. Here 5 coins are there. That's why better to apply the binomial distribution here. So n is 5 given here. Then p is probability of getting head. You know very well, when a coin is tossed, probability of getting head is 1 by 2 only. Q is also 1 by 2. So consider p of x, 5cx, p power x, q power n minus x in the sense 5cx, 1 by 2 power x, 1 by 2 power 5 minus x. 5cx into 1 by 2 power x, x is 0, 1, 2 and so on 5. Then p of x equal to 3 in the sense x equal to 3 substitute. P of x greater than or equal to 1 in the sense 1 minus p of x less than 1. 1 minus p of x equal to 0, substitute and simplify. P of x less than or equal to 2. P of x equal to 0 plus p of x equal to 1 plus p of x equal to 2. Consider and simplify. Like this, one more problem is given. It is also similar to that only, but it is a coin problem. But it is now, this one is dice problem. 6 dice are thrown 729 times. How many times do you expect at least 3 dice to show 5 or 6? N is 6. It's 729 in the sense it's capital N. At the time of finding the expected value, they will consider 729 into respective probability. That's why don't bother about 729 here. Small n is 6 dice only. That's why n is 6. Then probability of getting 5 or 6. Total is 6 faces. 1, 2, 3, 4, 5, 6. In that 5 or 6 in the sense 2 favorable. 2 by 6, 1 by 3. Then Q is 1 minus P, it is 2 by 3. Binomial distribution is P of x equal to 6cx, 1 by 3 power x, 2 by 3 power 6 minus 1. Then probability of getting at least 3 dice, show 5 or 6 in the sense, P of x greater than or equal to 3. Greater than or equal to 3 in the sense 3 plus 4 plus 5 plus 6 in the sense it's some whole length. Do one thing. So go through that back. 1 minus P of x less than 3. Less than 3 in the sense 0 plus 1 plus 2 plus 3. Respective values substitute and simplify. Now we want to find expected number of times x greater than 3. That's why 729 into whatever the probability they will get, that substitute here and simplify. 233 times out of 729 it shows 5 or 6 in at least 3 dice. Now these are the different problems related to binomial distribution. Then enter into the Poisson distribution. It's also similar to binomial only, but slight differences are there. So the properties are like binomial only, but what's the difference between Poisson and binomial? First identify. Two cases are there. One case is based on p value, another is based on n. If n is large, p is small, then we can use the Poisson distribution. N is large, p is small. Observe one small example here. In the case of finding the probability of errors in a textbook. The text was in a textbook of one page, suppose. In one page, how many words are there? Just approximately 300 words are there, suppose. How many words are mistake here in the sense? Maximum 1 or 2 only. So 2 by 300 in the sense it's very small. N is 300, that's why big. P is 2 by 300, it's very small. That's why when we use Poisson distribution means when n is large and p is small, then you can use the Poisson distribution. It's the base thing. Then this Poisson distribution was discovered by French mathematician Simon Denis Poisson. So that's why only this distribution is called Poisson distribution. A discrete random variable x assumes the value 0, 1, 2 and so on with the probability mass function p of x is e power minus lambda, lambda power x by x factorial. 0 is x is 0, 1, 2 and so on equal to 0. This is called a Poisson distribution with parameter lambda. Simply this considered as x follows p of lambda means x follows Poisson distribution with parameter lambda. So what are the different examples means is already we discussed. Number of mistakes in a page of a book. Number of accidents recorded in a city. Number of defective items produced by a company. Number of telephone calls in a office. By seeing all these examples, here n is large and the probability of getting that respective is less. That's why only these situations we can use the Poisson distribution. Here summation p of x is 1. So basing on that summation lambda power x by x factorial is e power lambda. So some properties are there. Mean of Poisson distribution is expectation of x is mu1 dash summation x into p of x. Substitute and simplify. It gives lambda. Then variance is mu2. So mu2 dash minus mu1 dash whole square. Mu2 derived here. This derivation is known only for you. So do your own. Then expectation of x into x minus 1 is lambda square. So like mu2 dash is lambda square plus lambda. Variance mu2 is mu2 dash minus mu1 dash whole square. Lambda square get cancelled. Variance of Poisson distribution is also lambda. So that's why. So if mean equal to variance, then the distribution is called Poisson distribution. In Poisson distribution, mean equal to variance. Non-central of Poisson distribution are mu1 dash is lambda, mu2 dash is lambda square plus lambda, mu3 dash is lambda cube plus 3 lambda square plus lambda, mu4 dash is lambda power 4 plus 6 lambda cube plus 7 lambda square plus lambda. Based on these non-central moments, consider the central moments here. mu1 is 0, mu2 is lambda, mu3 is lambda, mu4 is considered. Coefficient of skewness, coefficient of kurtosis also you should take. Mg of C of Pg of Cg for routine only. Relationship between cumulants and moments also consider. Then additive property of Poisson distribution you know very well. So then Poisson distribution tends to binomial distribution tends to Poisson distribution when it in the sense already we discussed. N tends to infinitum in the sense n is large, p tends to 0 means p is very small. So that's why np is lambda, p is lambda by n, q is 1 minus lambda. Poisson distribution tends to normal distribution when it in the sense for large values of lambda. Mode of Poisson distribution is also lambda only. So when it in the sense lambda is an integer, that value and before value. Lambda is not an integer, integral part of lambda is called mode. Then some few problems are there here. All these problems are very easy only. A hospital switchboard receives an average of 4 emergency calls in a 10 minutes interval. So what is the probability that there are at least 2 emergency calls? There are exactly 3 emergency calls in a 10 minutes interval. So lambda average calls in the sense mean of Poisson distribution here. Lambda is 4. Then Poisson distribution function consider e power minus lambda in the sense e power minus 4 power x by x bar. Then easily can identify at least in the sense maximum, at least in the sense here not at least in the sense from that value, at most in the sense up to that value. P of x less than or equal to 2, x equal to 0 plus x equal to 1 plus x equal to 2. All these values substitute and simplify. P of x equal to 3, substitute and simplify like this, exactly 3 calls. Then a company produces 3% of defective items manufactured from the production process. Find the probability that a sample of 100 items contain no defective items, at least 2 defective items. By seeing a defective case, we can use the Poisson distribution. Is defective in the sense it's related to p-value. So then number of items given, based on that p and n, you should find the lambda value. Then go through that no defectives in the sense x equal to 0, at least 2 defectives in the sense, already I told clearly, at least in the sense greater than, at most in the sense less than. So first find the lambda. So p is 3%, 3 by 100, 0.03. N is 100 here. So lambda is np 3. Then Poisson distribution function is this one. So p of x equal to 0 means this value. P of x greater than or equal to 2. 1 minus p of x less than 2. Less than 2 means 0 plus 1. It's clear. Then next, a car hire firm has 2 cars which it hires out day by day. The number of demands for a car on each day is distributed Poisson with mean. Clearly given that Poisson distribution with mean in the sense lambda. Calculate proportion of days on which neither car is used. Demand is refused in a year. 2 points you should find. Neither car is used. Neither car is used in the sense no use in that particular day. So that's why P of x equal to 0. Demand is refused in a year in the sense. So lot of demand is there in the sense P of x greater than 2. Why? Because of 2. Particularly why 2 consider in the sense here. So a person has, see why 2 particularly consider means 2 cars are there, that's why refused in the sense P of x greater than 2. So that 2 should find. So clearly given that lambda mean is lambda 1.5. P of x write down here, Poisson distribution mention here. So e power minus 1.5 into 1.5 power x by x factorial. So no demand in the sense, neither car is used in the sense, so no demand. That's why P of x equal to 0 should. Then the demand is refused in a year means more demand. So 2 cars are there in the sense 2 are not available. P of x greater than 2. Before that, so proportion of days on which there is no demand in a year. So that's why 365 multiply. So 81 days no demand. Then more demand is there in the sense P of x greater than 2. 1 minus p of x less than or equal to 2 pi, 0 plus 1 plus 2. Respect to probability, substitute and simplify. 0.1912 is proportion of days when car is over demand, in the sense multiply with 365. 70 days is not available for that particular 2 cars. Now observe another problem here. A book contains 43 mistakes in 585 pages. Find the probability that there will be no mistakes in randomly selected 10 pages of the book. Here actually small is n is 10 only. This 585 you can use the proportionate situation. P is the number of mistakes by total pages. So that's why P is 43 by 585. It is 0.0735. P is small, N is somewhat bigger. Lambda is NP. So 0.735. The Poisson distribution considered like this. P of x equal to 0. No mistakes in 10 pages. That's why like this consider 47.95% scopes are there with no mistakes. Then another last sum. If a Poisson distribution is such that 3 by 2 p of x equal to 1 is p of x equal to 3, then find difference. Based on this, you should find the lambda value mainly. So, Poisson distribution given clearly here. X equal to 1 substitute, x equal to 3 substitute. After cancellation, lambda is 3. Like this. Then Poisson distribution at x greater than or equal to 1. 1 minus p of x less than 1, consider 1 minus p of x equal to 0. Then 2 less than or equal to x less than or equal to 5. No option is there for us here. P of x equal to 2 plus p of x equal to 3. Like x equal to 4, 5. E power minus 3 substitute 0.7163. These are the different discrete probability distributions. 3 are there: Bernoulli, binomial and Poisson. You should more focus on these 3. Thank you.